So moving along here, let's look at a few more problems in this review. Let's look at number 4, finding the inverse of the following functions and then determining if the inverse is a function. So what I was describing to you when you're trying to find an inverse of a given function, the trick is knowing what happened to the original function, so that way when it comes to writing the inverse function, you know how to do it, because the connection between the function and its inverse is one undoes the other. The roles of x and y switch. So if we're trying to write the inverse of this function here for a, let's understand clearly what happened to x here. If I were to evaluate what happened to x, the first thing that happened here is that we subtracted 24 from it. The second thing that we did is we squared it. So when it comes to finding the inverse of a function, we have to start from the bottom up. So the first thing that we have to deal with is we have to address this issue right here of squaring it. And to do that, we have to do the opposite of squaring, which is the square root. So what we're going to do to our function is take the square root first. After we do that, then we're going to add 24. So how does this look when we write the inverse function? Well, when we're preparing to write our inverse function here, let's write down x and let's do these two things in that order to x. First, take the square root. Because it's a square root, there's two possible answers here, plus and minus. Check. Next, we need to add 24, making sure that we carefully do it so that way it's after we square rooted. How about that? Mission accomplished. Now what about trying to determine if the inverse is a function? Defining if the inverse is a function, sometimes this can be, some inverse functions are pretty tricky to graph, like you're going to see with b. So look at the original function, graph that, and taking a good look at this original function here, when I graph x minus 24 squared, we have this parabola here. Notice that a horizontal line will hit that graph at two spots. So it's going to fail the original, the original fails a horizontal line test, which means that the inverse is not going to be a function. Let's look at the second one here. First, understand what happened to x. First thing that happened to x, we had to multiply by 5. Then we had to add 10, and then the last move we made there is we cubed it. So to find the inverse, we reverse those steps, deal with 3 first. Cubing, the opposite of cubing would be a cube root. Deal with the adding of 10 by subtracting 10, and then divide by 5. So if we do that, 2x, cube root, don't need plus minus here because it's an odd root. Then we need to subtract 10 afterwards, and then to divide by 5 after we've done these two things, the only way we can do it is use a big fraction bar just like that. So there's our answer. I don't know why I have f of x there. Sorry about that. It should be g of x, inverse of g of x. Then I probably did the same thing on the inverse here. Another way we could write it is we could write it like this. Divide there and divide there. A cube root of x divided by 5 is no different. Let's highlight that. Cube root of x divided by 5 is no different than taking 1/5 times the cube root of x. It means the same thing. Here, once again, pretty tricky to graph 1/5 times the cube root of x minus 2. So why don't we just graph the original and examine that one. Notice here, it's going to pass a horizontal line test here. Since it passes a horizontal line test, the inverse is going to be a function. Next, let's do some more composition of functions that we were doing earlier. Find g of f of x. Well, let's make f of x here blue, let's make g of x red, and make h of x here green. So in other words, if I want to figure out what g of f of x is, I need to make f of x the input into the function of g. So this needs to go right in there for that x. Notice what is noticeably absent here. Remember, I'm getting rid of this x, and I'm putting this in its place. So make sure we're not putting x in there twice. Now, when you're here, just go ahead and get rid of your parentheses. A little distributive property ought to clean that up. Very nice. And so we have 15x minus 30. Let's look at the next one. This time, now we have g of x being the input into x. So now we have 3, instead of x minus 6, now we have 3 times 5x minus 6. Let's multiply those two together, make that 15x minus 6. Done. Here, h of f of x. So now f of x needs to be the input right in there for that x. So notice how I handled that. Put f of x, which is 3x minus 6, put it in parentheses and squared that, because that's what this function wants us to do. Take whatever input you have and square it. Well, if my input is the entire quantity, 3x minus 6, I want to square that entire quantity. Now be careful. Remember what this 2 means. It's saying this, 3x minus 6 times 3x minus 6. We got to FOIL that. And don't forget, 3's along for the ride too. So just foiling that, we end up with this here, but then don't you forget about 3 and add those up. So now we have 39. Hooray!